Very good morning to all of you. Welcome to IFAS. तो आज कैरोथर्स का जो फोर्थ चैप्टर है, राइट, जो फोर्थ चैप्टर है रेडिकल एंड कार्बिन केमिस्ट्री, राइट, रेडिकल एंड कार्बिन केमिस्ट्री का जो प्रैक्टिस प्रॉब्लम चैप्टर के एंड में जो है, तो उसका सॉल्यूशन करेंगे विथ प्रॉपर मैकेनिज्म्स एंड टोटल डिटेल्ड एक्सप्लेनेशन, राइट. तो जुड़ते रहिए. जैसे कि मतलब कैरोथर्स का फर्स्ट चैप्टर हो गया, सेकंड हो गया, थर्ड जो पेरिसाइक्लिक रिएक्शन था वो भी हो चुका है. तो आज जो फोर्थ चैप्टर है यानी कि रेडिकल एंड कार्बिन केमिस्ट्री, राइट, रेडिकल एंड कार्बिन केमिस्ट्री, तो वो चैप्टर आज हम लोग कर लेंगे. ठीक है, चलिए. तो व्हाट इज द फर्स्ट क्वेश्चन? देखिए, so suggest reagents, right? Suggest reagents and conditions for the decarboxylation of the carboxylic acid 1 to give this compound. Look, this group, right, is replaced by hydrogen, right? So this is a basically decarboxylation reaction. Decarboxylation reaction, right? Particularly, this is a name reaction, that is Barton decarboxylation, right? Barton decarboxylation. So suggest reagents and conditions. Okay. So first of all, we have to at first activate, right? We have to at first activate this carboxylic acid group. Then we will make some active ester, right? Or you can say redox active ester. Okay. So that active ester will undergo proper decarboxylation. Look. So this is the structure, right? What was the structure? OH, COOM. Okay. OH is OOME and WOC is attached, right? नाइट्रोजन का साथ एक WOC group attached है. And now this is OOH, right? This is COOH, right? So in the next step, first step, we have to give this compound with some base followed by this molecule, this reagent with another base. So after giving this type of reagents, okay, after giving this type of reagents, we will generate active ester, okay, that will look like this. वो कुछ प्रोडक्ट इस तरह होगा. COOME. So here double bond O nitrogen, double bond S, and this. Fine. This is now we have made this. We have tuned the initial acid group, right? We have tuned the initial acid group into an active ester. So now under any radical condition, so we have used a sort of radical initiator, then tributyl tenhydride, right? So then from this we can produce this radical, right? We can produce this radical, right? Tributyl ten radical. Then this type of mechanism will be followed. One electron will move here another electron will make a bond with tributyl tin radical, right? And then this bond, one electron will move here and another electron will make a bond, carbon nitrogen bond. Then this bond, one electron will move towards this direction and another will move here. So carbon dioxide gas will be evolved, right? So minus carbon dioxide, and we will get this OH, COOMe, nitrogen, POC, and this radical. Okay, and then it will be quenched with H dot, and we will get our decarboxylated product. We will get our decarboxylated product, right? Okay, so this is a name reaction which is Barton's decarboxylation. So basically at first we have made our initial COOH group into an active ester, okay, into an active ester. Good morning, Shivam. Hi. Good morning, Ketan sir. Okay, so next problem. Look. Sorry. So explain the formation of the alcohol 4. Explain. Good morning, Abhishek. So explain the formation of the alcohol 4 from the epoxide 3. Okay. Look, solving problems is okay. ठीक है, प्रॉब्लम को तो सॉल्व करना ही है, वो तो अलग बात है, लेकिन कॉन्सेप्चुअली करना है, राइट? समझ के करना है, कॉन्सेप्ट को अच्छे से समझ के फिर अगर हम लोग प्रॉब्लम सॉल्विंग करते हैं तो कुछ बात बनेगा. देखिए, एपोक्साइड है 5 मेंबर रिंग विथ 3 मेंबर रिंग इनिशियल सबस्ट्रेट. प्रोडक्ट में क्या है? प्रोडक्ट में है 2 फ्यूज्ड 5 मेंबर रिंग, 2 फ्यूज्ड 5 मेंबर रिंग. तो कैसे होगा, कैसे हो सकता है? तो और रिएजेंट में क्या है? रिएजेंट में क्या है? रेडिकल इनिशिएटर, 1 रेडिकल इनिशिएटर एंड ट्राइब्यूटाइल टिन हाइड्राइड. देखिए, सो द फर्स्ट स्टेप, पहला जो स्टेप है वो तो मैं यहां पे ही करने वाला हूं. तो देखिए, द वेरी फर्स्ट स्टेप, ट्राइब्यूटाइल टिन रेडिकल विल जेनरेट, राइट? ट्राइब्यूटाइल टिन रेडिकल विल जेनरेट, राइट और रॉन्ग? कमेंट में बोलिए. ट्राइब्यूटाइल टिन रेडिकल विल जेनरेट, राइट और रॉन्ग? Right? Then this tributyl tin radical, right? This will make a bond with this carbon. Okay. Then this electron will move here. It will move here, and another electron will be on oxygen atom. देखिए, ठीक है? तो प्रोडक्ट कुछ इस तरह का आएगा. Listen, view, this bond is forming, right? Bond is forming. Bond is this one. So, okay, देखिए. तो नेक्स्ट स्लाइड में हम लोग प्रोडक्ट लिखते हैं, ठीक है? फाइव मेंबर्ड रिंग, ओके, 5 मेंबर्ड रिंग, ठीक है? 1 2 3 4, ओके, 1 2 3 4 OBN, right? Benzoyl oxy group. Then with this O dot, right? With this below the plane, O dot, right? Fine. And now one double bond will be here. So one double bond will be here, and this bond 1 2, okay. So 1 2, this is SnBu3. First, after first रेडिकल अटैक, यस दामिनी, एकदम सही है। तो देखिए आफ्टर फर्स्ट अटैक ऑफ ट्राइब्यूटाइल टीन रेडिकल, दिस टाइप ऑफ इंटरमीडिएट विल जेनरेट, राइट। जल्दी से कमेंट में बताइए, ठीक है, ऐसा होगा। अभी देखिए ऐसा अगर होगा तो मुझे प्रोडक्ट तक जाना है। प्रोडक्ट में क्या है, टू फ्यूज्ड 5 मेंबर्ड रिंग। तो 5 मेंबर्ड रिंग को क्रिएट करना है, राइट। 5 मेंबर्ड रिंग को क्रिएट करना है, तो कैसे करेंगे, कैसे करेंगे 5 मेंबर्ड रिंग। हम इस इंटरमीडिएट से 5 मेंबर्ड अगर करना है तो इंटरनल अटैक करना होगा। और कौन सा पोजीशन से इंटरनल अटैक करना है, देखिए ये जो 1 2 3 4, right, then 5, then only we can form a type of fused 5 membered ring, then only we can form a type of fused 5 membered rings, right। देखिए इसके बाद जो स्टेप है वो है 1 5 हाइड्रोजन एब्स्ट्रैक्शन। देखिए ऑक्सीजन को अगर हम लोग नंबरिंग देते हैं 1 2 3 4 5, तो रेडिकल यहां से मतलब रेडिकल को यहां पे जनरेट करना होगा, राइट। 5 पोजीशन पे C5 कार्बन पे अगर रेडिकल जनरेट होगा, देन ओनली इट कैन अटैक ऑन दिस पोजीशन, दिस विल मूव हियर एंड दिस ट्राइब्यूटाइल टीन ग्रुप विल बी eliminated, right। So then only we can produce some fused 5 membered ring, okay। So the next step is 1 5 hydrogen 1 5 hydrogen abstraction, 1 5 हाइड्रोजन एब्स्ट्रैक्शन। अभी देखिए एक डाउट आपको हो सकता है कि यहां से कैसे इतना दूर में मतलब हाइड्रोजन एब्स्ट्रैक्ट कर लेगा। देखिए ये तो सिंगल बॉन्ड है, राइट। सो इट कैन रोटेट एंड इट कैन ओरिएंट इटसेल्फ accordingly, right। it can orient itself accordingly so that this position and this oxygen radical, this oxy radical can be in close proximity, so that this 1 5 hydrogen abstraction can take place, right। so our next intermediate will be like this, right। this will be OH, fine, this will be OH, because after hydrogen abstraction this will be OH and radical will generate at C5 position। so 1 2 3 1 2 3 1 2 3 4 1 2 4 OBN, and in this position radical is forming। so again I am numbering 1 2 3 4 5, so 1 2 3 4 5, look, the initially radical was on the oxygen atom, but after 1 5 hydrogen shift it generates on C5 position। now this moiety, this structural conformation will really dictate you that this type of attack can occur, right। so one bond will form like this, and another electron will move here, from this bond another electron will come, and again tributyl tin radical will generate, and these cycles carry on, okay। so our final product will be at first minus SN dot BU3, okay, this group will be eliminated, right। so then our final product will be here a double bond, and now here a 5-member ring. This group is below the plane, so it also should be below the plane. So hydrogen is above the plane and OH was in above the plane from the very beginning of this reaction, and here OBN group is present. Look, this is our final destination, this is our final product, and look what is the structure given in the problem, same structure, right। and here the stereochemistry of OBN cannot be predicted because it is sp3 hybridized carbon, right। look, I cannot tell it that it is above the plane, it can be also below the plane, right। so that's why in the problem this broken bond like this is given, okay। so very good problem, very good concept has been used in this problem, right। एकदम सही है शिवम, ऑक्सीजन रेडिकल अटैक एकदम सही है। तो क्या कॉन्सेप्ट यूज हुआ था, तो पहले ट्राइब्यूटाइल टीन रेडिकल यहां पे अटैक करेगा, उसके बाद ऑक्सी रेडिकल विल जेनरेट लाइक दिस, ठीक है, ओ डॉट प्रोड्यूस होगा, दिस ओ डॉट देन will undergo 1,5 hydrogen shift. 1,5 hydrogen shift, right, dosto? After 1,5 hydrogen shift, radical will generate at C5 position. Then this type of exo, you can tell it exo 5 trig, right? 5 exo trig, right? Because 5-member ring is forming and attack is occurring from this side, and this is sp2 hybridized. So 5 exo trig type of attack is taking place, and then our final product we will get our final product with proper stereochemistry, right? चलिए नेक्स्ट प्रॉब्लम देखते हैं. देखिए, explain using benzoyl radical and N-hydroxythalimide the formation of the ketone 5. Okay, explain the formation of the ketone 5. तो ये जो ketone है, ठीक है, the final product, how can we explain this formation? Okay, this is the question. How can we, Akash? Yes, Baldwin's principle. For cycliation, we generally follow the Baldwin's principle. Very good, Akash. Okay, चलिए. तो पहले हम क्या करते हैं, ये जो ग्रुप है ना, दिस ग्रुप, ओके, दिस ग्रुप, इसको R1 कंसीडर कर लेते हैं, ठीक है, और क्या करते हैं, ये जो ग्रुप है, ठीक है, ये जो ग्रुप है इसको R2 कंसीडर करते हैं. सो to make our problem a little bit easier, we will just consider that the bulky groups as R1 and R2. Okay, so in our substrate we will get first R1 CHO, right? R1 CHO, and this is double bond R2. Fine, this is double bond R2. Okay, and in the reagent they gave this, and okay, this is a this is a peroxy reagent, right? So from this, in heating condition, we will get benzoyl radical. Okay, we will get benzoyl radical. So after that, catalytic N-hydroxythalimide. तो इसको हम N-hydroxythalimide ऐसे भी बोल सकते हैं, ठीक है, NHPI. ओके, करते हैं. चलिए, so we can solve this problem by taking simple cycles, or also we can solve it by step. Okay. Okay, right. एकदम. So fine. Okay. Now N-hydroxythalimide. Okay, N-hydroxythalimide, we can write this OH bond like this. Okay, fine. So now benzoyl radical, right? Benzoyl radical will generate. So simply I am writing B dot. Okay, benzoyl radical. Then it can capture this like this, and O dot will generate it. Okay, so we will get in our system like this, double bond O, N, O dot, and again fine. This species can produce acyl radical. This is very important. Okay, acyl radical. So from aldehyde, it can again, this dot can again capture this proton and reproduces this one. Okay, and we will get some sort of acyl radical. Okay, acyl radical. The name of this radical is acyl radical, right? Acyl radical. Now look, in our system we have already produced acyl radical. Okay, so now in our system we have also have some alkene, right? Our alkene is like this, R2. So next attack, simply this radical can attack at this position and we will generate a secondary radical, right? Look, is acyl radical. This is acyl radical, right? So in our system we have also this species, right? देख लेते हैं हमने क्या कंसीडर किया था, दिस ग्रुप को R2, राइट, एंड दिस ग्रुप को R1. ओके फाइन, नो प्रॉब्लम. then one electron will make a bond like this, another electron move to this position to make a secondary radical, right? Secondary radical. So R1 double bond, one bond is forming. So this is the form CC, new CC bond, and we will get this radical R2, right? ठीक है? तो again एन हाइड्रोक्सीथैलिमाइड सिस्टम पे प्रेजेंट है, राइट? एन हाइड्रोक्सीथैलिमाइड सिस्टम में प्रेजेंट है कि नहीं है? तो अगेन फ्रॉम दिस इट विल टेक अ प्रोटॉन एंड अगेन O dot will regenerated and the cycle will be continue. Cycle will continue by itself. ठीक से लिख देते हैं इसको. ओके, R1 double bond O 1 2 3 1 2. Fine. Now just R1 और R2 का स्ट्रक्चर आप लोग लिख लीजिए. देखिए प्रोडक्ट आ जाएगा आपका. देखिए प्रोडक्ट आ जाएगा. ठीक है? तो इसमें क्या कॉन्सेप्ट यूज हुआ है? फर्स्ट, generation of acyl radical from aldehyde, a new concept, right? Generation of acyl radical from aldehyde with the help of N-hydroxyhalimide in presence of any radical initiator. Okay, देखिए कार्बीन और रेडिकल, ठीक है, जब हम लोग जनरल ऑर्गेनिक केमिस्ट्री में रिएक्शन इंटरमीडिएट्स पढ़ते हैं, ठीक है, रिएक्शन इंटरमीडिएट्स पढ़ते हैं, उसमें कार्बोकैटायन होते हैं, कार्बेन, फिर आते हैं कार्बीन और रेडिकल, राइट? सो कार्बीन और रेडिकल रियली very important reaction intermediates, not only for CSIR, NET or GATE. We have to know the actual chemistry, right? Actual chemistry of carbene chemistry and radical chemistry. So that's why that, solving of Carruthers problems is really important, because from these you can get some new concept, right? जैसे कि यहाँ पे आज क्या मतलब इस प्रॉब्लम से हम लोग क्या सीख पाए कि generation of acyl radical can be achieved from aldehyde and it can attack any alkene system, right? Any alkene system. अभी देखिए यहाँ पे अगर कॉन्सेप्ट यूज मतलब न्यू कॉन्सेप्ट अगर यूज करूँ कि मतलब जो एल्कीन है, ठीक है, जो एल्कीन है, अगर उसमें हम इलेक्ट्रॉन विथड्रॉइंग ग्रुप अटैच कर दे, राइट? एल्कीन में अगर इलेक्ट्रॉन विथड्रॉइंग ग्रुप मैं अटैच कर दूं तो इसका जो लूमो है, राइट, लोएस्ट अनऑक्युपाइड मॉलिक्यूलर ऑर्बिटल, दैट विल बी, अगर मैं इसको यहाँ पे इलेक्ट्रॉन विथड्रॉइंग ग्रुप अटैच कर दूं तो इसका लूमो का एनर्जी लेवल डिक्रीज हो जाएगा. तो फिर ये जो अटैक है, जो होमोलूमो इंटरेक्शन है, वो बहुत इजियर हो जाएगा. तो यानी कि सपोज इलेक्ट्रॉन विथड्रॉइंग ग्रुप, राइट, दिस टाइप ऑफ एल्कीन कैन अंडरगो दिस टाइप ऑफ केमिस्ट्री सो नाइसली, राइट? अगेन देखिए आफ्टर द attack here a radical is formed, right? So basically we can tell it a secondary radical, right? Secondary radical. तो ये जो R2 ग्रुप है, अगर ये R2 ग्रुप ऐसा कोई सिस्टम है जिसमें कि रेडिकल का कॉन्जुगेशन पॉसिबल है, तो फिर ये जो इंटरमीडिएट है, ये जो स्पीशीज है, वो ज्यादा स्टेबल होगा, राइट? ज्यादा स्टेबल होगा. तो यानी कि अगर स्टाइरिन टाइप ऑफ सिस्टम हो तो फिर acyl radical can easily attack here and generate a radical adjacent of a benzene ring which is very stable, right? So this type of concepts can be asked. Next देखिए draw the structures of the intermediate, draw the structures of the intermediate radicals to explain the formation, to explain the formation of the three ketones 7 to 9. Okay, fine. देखिए फिर से suppose trialkyl tenhydride. Okay, trialkyl tenhydride is given, trialkyl tenhydride is given, and our system we have some iodo derivative, right? Some iodo derivative. Okay, some iodo derivative. So now first a kind of alkynyl radical will generate, right? So after formation of trialkyl tin radical, it will capture this iodine, and here so Q3 SN dot, right? Q3 SN dot radical. Okay, so it will capture this iodine and a sort of alkynyl radical will generate. देखिए स्ट्रक्चर को पहले ड्रॉ कर लेते हैं. 1 2 3 4 5 1 2 3 4 5 6 7. ओके 1 2 3 4 5. तो 1 2 3 4 5 ऐसा कुछ है, राइट? फाइन. यहाँ पे डबल बॉन्ड, ठीक है, यहाँ पे CH3, तो यहाँ पे रेडिकल जनरेट हुआ है आफ्टर एब्स्ट्रैक्शन ऑफ द आयोडीन, राइट? फिर यहाँ पे मिथाइल, देन 1 2 डबल बॉन्ड. ठीक है, ओके, डबल बॉन्ड मिथाइल. ठीक है, ओके. देखिए फास्ट क्या होगा, देखिए चलिए नंबरिंग करते हैं. ठीक है, तो सपोज 1 2 3 4 5. ओके, so 1 2 3 4 5. First this radical can approach here, and here a radical will generate. So basically 1 2 3 4 5. So 5-membered ring is forming. This center is sp2 hybridized. Attack is occurring from internal side. So we can tell it 5 exotrig according to, जैसे कि आकाश कुछ देर पहले बोले कि बाल्डविन्स प्रिंसिपल, तो according to that principle or that rule 5 exotrig, so generation of a 5-membered ring 1 2 3 4 5. Okay, fine. Okay, so one double bond is here and this position is attacking here, right? So here a methyl group will be there, and this in this position one methyl group present. Then type of radical, right? This type of radical will generate, and then 1 2 3 4 1 2 3 4. बढ़िया से लिखता है 1 2 4. Okay, 1 2 3 4 and 1 2 4, and a double bond is present, right? So like this. Fine. So now if this simply coins the reaction, that means reacts with H dot, then we will get our first product, right? Then we will get our first product. Okay, डबल बॉन्ड में कुछ गलती हुआ शायद, नहीं ठीक ही है, डबल बॉन्ड ठीक है. Fine, we will get our first product, right? So first product, right? ठीक है, फर्स्ट प्रोडक्ट. अभी देखिए ये जो रेडिकल है इसका पास दो ऑप्शन है, राइट? फर्स्ट ऑप्शन की simply coinced with H dot and first product we will get, but it has another chance also which will give our second product, that is क्यों number 8. Okay, चलिए देखते हैं कैसे हो रहा है. तो यहाँ पे देखिए, this radical can undergo 1, 2, 3, 4, 5, 6. That is 6. Okay, that is 6. Simply 6 exotrig, right? 6 exotrig. I think this will be endo. Yeah, because the attack is outside, right? Attack is occurring from the outside, so it will be endo, right? This will be endo. Fine. So this radical can make a bond like this, and here a radical will generate. Fine. So we will get our next product, something like this. Fine. Okay, and 1, 2, 3, 4, 5, 6. So from this we will get a 6-member ring. Here double bond O, here double bond O, and attack is here. So and now a radical will generate here, right? And this will be methyl. And in this radical has also two chances. First, if this is quenched with H dot, then we will get our second product. But now, if this radical is if this radical can undergo another further type of cyclation, then we will get 1, 2, 3, 4, 5, right? So this radical can make a bond like this, and here here we can make a radical. So we will get radical. Okay, so 1, 2, 3, 4, 5, 5-member ring, right? 5-member ring, and then it is also fused with a 6-member ring, right? So 1, 2, 3 type of structure. I think I should write the structures properly. Otherwise, it will be so difficult to understand, right? So this type of structure, right? This type of structure. Okay. And this is used with like fine. Here double bond O, and one methyl should be here, and another methyl should be here, right? Yeah. Fine. So here should be one methyl group, and here should be one methyl group, right? And it will coincide with H dot. It will coincide with H dot. Well, attack is from here, right? 1, 2, 4. 1, 2, 3. Okay, one methyl is already here. Right. No mistake. One methyl is already there, right? That's why I'm getting confused. That methyl kahan se aa raha hai? One methyl is already there, right? One methyl is already there. Fine. Okay. So here will be another methyl group, but here is hydrogen, right? Okay, fine. CH3, CH3, CH3. This is our product. Third ketone. Fine. So from this problem, we have learned that how we can use our Baldwin's principle. Okay, our Baldwin's principle, that is a thumb rule for favorable cyclization, okay, for favorable cyclization, so this type of alkynyl radical can initiate the intramolecular cyclization initially by 5-exo trig. Then this radical has two options, दो options है इसके पास कि पहले ये H डॉट के साथ जुड़ के फर्स्ट प्रोडक्ट दे सकता है, या फिर इस रेडिकल फिर से इंट्रामोलिकुलर साइक्लिएशन के तहत की 6 एंडो ट्रिग रूल फॉलो करते हुए ये रेडिकल का जनरेशन हो सकता है, राइट। अभी ये रेडिकल फिर से इसके पास दो ऑप्शंस है, ये रेडिकल या तो H डॉट के साथ कोइंच होके अपना जो सेकेंड कीटोन है वो प्रोड्यूस कर सकता है, या फिर ये this radical can undergo again 5-exo trig type of cyclization and will produce our third ketone, right? Okay. So next problem, देखिए, next problem, suggest a mechanism for the formation of the cyclohexanone, okay, that involves a phenyl thiocatalyst. Okay, look, from this AIBN, okay, this is a radical initiator, we can generate KHAC dot, right? KHAC dot. So this, the name of this radical is phenyl thioradical, right? Phenyl thioradical, okay? कमेंट क्या आया है देखते हैं। तो फिनाइल थायोरेडिकल, ओके, फिनाइल थायोरेडिकल, ठीक है, ओके। तो दिस फिनाइल थायोरेडिकल, okay, this phenyl thioradical can attack on the, can make a bond with this carbon first. This radical can move here, this bond can cleave like this, and here at this position a radical can be generated. So what we have got something like this, right? KH dot. So with this SPH is attached. Fine. One bond is forming. Double bond. Yes. CH2, okay. And this. Okay, fine. So this is our first product. Product means first radical species. Then look carefully. The system, a byproduct is benzophenone, right? A byproduct is benzophenone, right? So look, this radical, right? This radical can move here. One electron will move here, another electron will go there, and this will also, sorry, this electron, one electron will be there and another will be here. Okay. So basically we will forming C double bond O dot. Okay. Fine. Look. So we are getting a product. ठीक है, पहले इसको ठीक से लिख देता है तो फिर आसानी होगी, राइट? KHS, okay, double bond. Okay. So from this something is present, right? H and PH. Fine. Here a radical was there. Fine. Okay. So now this radical will come here. One electron will come here. Another electron go here. Okay. From this bond we will get CH2 dot and another electron will be. So basically benzophenone is removed, right? Benzophenone is removed. So minus CHO. After that we will get something like this. Double bond O H2 dot, double bond O H2 dot. Now 1, 2, 3, 4, 5. So wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 4, 5. Okay. So if I put the numbers from this carbonyl carbon 1, this is carbonyl carbon, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. With 5 SPH ring, SPH group is attached, double bond is in between 3 and 4, right? This is our next radical. Look, in the system, alpha beta unsaturated ester is present, right? Alpha beta unsaturated ester is present. Few minutes before, I have told you that if any electron withdrawing group is attached with any alkene, then the energy of the LUMO will be decreased. So electron donation or any kind of attack becomes much more easier, right? So look, here we have double, here we have double bond ester, right? Fine. So this radical will make a bond carbon, and this type of radical we will generate. Fine. So we have something double bond O H2. Okay, H2 1, 2, 3. 1, 2, 3. Fine. 1, 4. This is C double bond O tertiary butyl group. Fine. And here radical will be here, right? Fine. Then 1, 2, 4, 5. 1, 2, 4, 5. Here SPH group is attached. SPH group is present, right? SPH group is present and double bond. Okay. Fine. This type of radical will generate. Then 1, 2, 3, 4, 5, 6. Look, this radical can make a bond with this carbon. One electron will involved here. Another electron will go there. From this bond, one electron will make here and bond, creating a CH2 CC double bond. And again, phenyl thioradical will be regenerated. Phenyl thioradical will be regenerated, right? Phenyl thioradical will be regenerated. Okay. So our product will be 1, 2, 3, 4, 5, 6. 6-membered ring, right? Here double bond O. So if I'm just giving numbers, right? This will be suppose 1, 2, 4, 5, 6. Then our ketone is number 4, right? So suppose this is 3, this is 2, this is 1. Then here C double bond O tertiary butyl group is present. Double bond O C double O ester group is present, and with the 6, that is 5, 6, right? With 6, this type of group. Fine. So like this mechanism, following this mechanism, our final product we can get it, right? ठीक है? Good morning, Sholanki. Good morning. Very good morning. Okay, चलिए. Look. First, this is our substrate. With this, some phosphorus elide, right? Phosphorus elide reagent is present. So first reaction will be a kind of Wittig reaction, right? So first reaction will be Wittig reaction. So then we know that from Wittig reaction we generate generally alkene. So that's why here alkene product is given, right? Alkene product is given. So the first step I am just drawing here, okay? So so look, suppose H3 plus HL, and this is minus. This minus will attack on this. This will. So look, till now just I am considering this group R, but is important, but for this I am just considering it as R. Okay, so this will be O minus. Okay, so this will be PPH3 plus, and here a Cl is attached, right? So simply then negative charge will attack on this phosphorus due to vacant p orbital, and you will get type of bond. Then this will take down like this, and we will get something like this. Okay, ठीक है? This will be our alkene product. This will be our alkene product, right? This will be our alkene product. Okay. Next, base is present. Look, next base is present. So now I will draw the proper structures. Okay. Now I will draw the proper structures, but okay, fine. Below the plane, OBN group is present, and above the plane, is 1, 2, 3. So our product is above the plane 1, 2, 3, 1, 2, 4 actually 1, 2, 3. Okay, 1, 2, 4. Here double bond Cl is present, right? And 2 methyl groups are present at this carbon. Okay. So this is our alkene product. According to the problem, this is our alkene product, right? This is our alkene product. Okay, this is our alkene product. So next, base is given. Base is given. Base is given, right? So first, here a proton is present. So base, at first we will abstract this proton and making here a negative charge. Okay, making here a negative charge. So I am just not rewriting the whole structure. Okay, just considering from here. So this will be our next species, and then alpha elimination of minus Cl minus. Okay, alpha elimination will generate a carbene. Alpha elimination will generate a carbene. Okay, alpha elimination will generate a carbene. Is 3, and with this above the plane, and now oxygen this group, and here below the plane OBN group is present, right? And this is above the plane, right? Okay, this is above the plane. Okay, and here another hydrogen is present below the plane, right? So now what will be the fate of this reaction? What will be the fate of this reaction? Carbene is generated. Carbene is really reactive, right? So it will undergo CH insertion. It will undergo CH insertion. Okay, it will undergo CH insertion. Okay, it will undergo CH insertion. But this carbene has two choices, right? This carbene has two choices. First, if I am just writing this CH3 as CH2 and H. So first, this carbene can insert itself between this CH bond, and it also can insert, or it also can undergo CH insertion into this CH bond. Okay, so you should always remember that methane CH has higher reactivity than methyl. So methane CH has always better reactivity than methyl CH in the carbene insertion chemistry. Okay, so basically it will prefer to insert in the methane CH insertion. Methane CH insertion. Okay. So that's why we will get a product like this. Product like this. Five-member ring, right? One, two, three, four, five. Okay. Okay. So this here double bond will be our product will be double bond will present here. So here two methyl group below the plane OBN is present. Okay, below the plane OBH is present. This double bond will start. So here a double bond, fine, and one methyl group, right? One methyl group. One methyl group should be double bond will be there. Okay, okay, fine. Double bond will be there and one methyl group. Okay, fine. Simple, we can numbering, right? 1, 2, 3, 4, 5. Just checking it again. Because our second carbon, this is first. 1, 3, 4, 5. Okay, fine. Fine. And this is the carbon with which the C5 carbon is attached. So, okay, all okay, fine. Okay. So, from this question, we have get knowledge that from alpha elimination, by alpha elimination, we can produce carbene. Okay, from alpha elimination, we can produce carbene, and carbene can undergo CH insertion reaction. But in the CH insertion reaction, always we should remember that methane means methane. You know, methane, methylene, methyl. Methyl means this one. Methyl means CH3. Okay, methyl. This is methyl. This is methylene and this is methane. So reactivity order is like this. Okay. So methane is highly reactive and methane is more reactive than methyl. So that's why this carbene, this carbene insertion, the CH insertion reaction, has occurred by this direction. Okay. So next problem. Look. So first of all, we should look that rhodium catalyst is given, right? Rhodium catalyst is given. Okay. So rhodium and in our substrate double bond N2, okay. So simply this rhodium catalyst can insert in this bond and it can produce a rhodium carbenoid like species, or we can say carbene like species. Okay, carbene like species, fine. So then this type of unsaturated this type of double bond species is given, and then it is called they told that cyclopropane intermediate is forming. Cyclopropane intermediate. Look, we know that this reaction, the basic reaction, that CH2 carbene, right? CH2 carbene can react with alkene in order to form cyclopropane ring, right? This is very basic chemistry. Yes. So this is very basic chemistry, right? So similarly, at first, this sodium catalyst can create a carbene here in this position. So we will get like this. Double bond O. Here another methyl group will be there, right? Then this double bond C double O Me. Okay, C double O Me. Fine. Here a carbene is generated, right? And in our system we have this type of species, right? So simply it will make a cyclopropane ring similarly as according to our basic chemistry. So we will generate a species like this. methyl from here. Okay, and now 1, 2, 3. 1, 2, 3. Okay, 1, 2, 3 trans, right? Okay, this type of stresses. Okay, type of this hydrogen, this COO-Me. You can consider it. This is stereospecific reaction, right? So the stereochemistry will be proper. Stereochemistry should be properly visualized, right? N2 elimination. Yes, carbene will form, right, by N2 elimination. Okay. So now this moiety, with this moiety, we can perform 3,3 sigma tropic rearrangement, right? 3,3 sigma tropic rearrangement. Look, 1, 2, 3. Again 1, 2, 3. So 3,3 sigma tropic rearrangement. 3,3 sigma tropic rearrangement. Sigma tropic rearrangement will be the result, and we will get okay. So this bond is breaking. So we will get 1, 2, 3, 4, 5, 6, 7 membered ring. 7 membered ring, right? 7 membered ring. But now we have to look the proper stereochemistry, right? We have to look the proper stereochemistry, right? So we have to draw at first. We have to draw at first the transition state. Transition state of this. Transition state of this 3,3 sigma topic rearrangement intermediate. Okay. So look, double bond O. This one is right. Double bond O, right? Double bond O, and sorry. This bond is indicating this bond 1, 2. Okay, this 1, 2 bond, right? This 1, 2 bond. Okay, so now simply, and with this COO-Me group is attached, right? With this COO-Me group is attached, right? So now like this, okay, and cyclopropane ring is there, right? So we can draw it. We can draw it like this. Okay, cyclopropane ring is there, and now this 2,3 bond. Okay, for the OAC group, okay, for the OAC group, we can place it here below the plane, and this methyl group, right? This methyl group we can place it above the plane. Okay, like this, because below the plane is already occupied, right? So like this. Now we can get our product with proper stereochemistry, which is a 5-membered ring, with fused with 7-membered ring, right? So we will get our product like this. Double bond O, methyl is above the plane. Okay, methyl is above the plane. Okay, methyl is above the plane. Okay, methyl is above the plane. So now a 7-membered ring will be formed. 1, 2, 3, 4, 5, 6, 7. Okay, 6, 7. Fine. OAC in below the plane. Okay, OAC is below the plane. So one double bond is going to form here, and another double bond is going to form 1, 2, 3 here, right? Here. Fine. And OAC is in below the plane. OAC is in below the plane. So this will be our stereochemistry, and one COO-Me group is present. So this will be our final product. Okay, this will be our final product. The stereochemistry of the final product is something like this. Okay, sorry. Here double bond, because this is a CH2 group, right? One CH2 group. So this will be that CH2 group and double bond should be present here. Okay, nice, fine. Okay, so this will be the transition state, right? This will be the transition state. Okay, this will be the transition state and this will be the final product. You have to know the proper only way to get the proper stereochemistry, that is this boat like transition state. Okay, fine. So next, explain the formation of lactam product 13 on treatment of the diazoketone. Okay, this is easy, right? This is quite easy. Formation of ketene followed by internal attack, right? This is quite easy. Formation of ketene. Okay. So, look. Here from this, at the first step is formation of ketene, right or wrong? Boliye, formation of ketene, right? Okay. So this bond, okay, this bond we can write it properly. Then only the formation of ketene is that step we can explain. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Nice. So, with this NH case present, right? Here double 1, 2, 4, 5. So here double bond N2, right? So double bond N2, you will write it different style. So here, here double bond O, and at this carbon or methyl group is present below the plane. Okay, below the plane, methyl group is present. Fine. So this double bond N2 we can write it N plus is C minus. Okay. So now this can go here, O minus, again come back, and this total group, okay, total group will move to this carbon and nitrogen gas will be eliminated. So it will form a ketene, right? It will form a ketene, double bond C. With this, one hydrogen is present, right? One hydrogen is present and another group is this total group, okay? So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, nitrogen, H, yes, and here one methyl group is present. Fine. Now simple, this lone pair of on the nitrogen will attack on this carbon. This will then this minus H plus H plus, and we will get our product. 5-member ring, right? This one 5-member ring. Fine. Double bond O, N, yes, and here below. This was easy. So first is ketene formation followed by internal cyclation. Okay, ketene formation followed by internal cyclation, right? Okay. So our last problem, this is our last problem, and from this problem also you will know a new concept. Okay, a new concept. Fine. So a synthesis of the questions too larger, right? Fine. Avoid it. The simple question is first again a rhodium catalyst is given, right? First again rhodium catalyst is given, and in our system we have this type of N2. Okay. So rhodium catalyst will insert itself into this bond and it will generate a rhodium carbenoid type of species, right? Rhodium carbenoid type of species, or we can say as carbene like species. Okay. So here the structural features, इसमें जो कीटोन और यहाँ पर भी एक डबल बॉन्ड O है, राइट. So after generation of carbene here, it will be internally trapped by this oxygen and it will form a halide. Look at the mechanism, okay. Okay, so fine. Here into this present, right? And after giving rhodium catalyst, we will get something like this, right? Something like this, right or wrong? Right? But here this radical will be internally trapped. This radical will be internally trapped, okay, with this oxygen. Fine, with this oxygen, and it will generate a halide like this. It will generate a halide like this. 1, 2, 3, 4, 5, 6. 6-member ring will form, right? 6-member ring will form. And here oxygen is present. Double bond. So oxygen will be positively charged. Here methyl. And this will be negatively charged, this carbon. And here a double bond is present. So now this is halide, right? Opposite charge at adjacent positions, we call it halide, right? So this is our halide. New concept, right? So formation of carbene, then internal trapping will generate this type of halide. Then simply just okay. Then in our ethylaldehyde, okay, phenaldehyde. Fine. This is, so this negative charge will attack at this carbonyl carbon. This pi electron cloud will attack from the oxygen at this carbon atom, and the positive charge of the oxygen will be neutralized. So we will get our product like this. One double bond here, a methyl group is present, right? And 1, 2, okay, 5-member ring, right? 1, 2, 3, 4, 5, okay. 5-member ring, here oxygen. Fine. And here we know the carbonyl carbon, that this type of aldehyde molecule will have a plane. So this attack can be from rephase or psi phase. So depending upon that stereochemistry, this will be the ultimate result, because ethyl can be at above the plane, and also it can be at below the plane. So that's why in the problem 2 different isomers are given, right? So ethyl can be at above the plane, and also ethyl can be below the plane. So this is a CSIR net chemical science mock test series, okay. So you can purchase it. In that आपको मिलेगा total test 35, okay. So these are our faculty members, chemical science, right? These are some fantastic results, okay. So thank you all. तो आज हम लोग कैरोथर्स का जो चैप्टर 4 था, हम लोग धीरे धीरे टोटल कवर कर लेंगे, ठीक है. तो चैप्टर 1, 2, 3 हो गया था. आज हम लोग चैप्टर 4 कर लिए, यानी कि रेडिकल एंड कार्बीन केमिस्ट्री. तो कल सुबह मिलते हैं चैप्टर 5 लेके, एंड लास्ट चैप्टर 6, चैप्टर 7 होगा ऑक्सीडेशन रिडक्शन, राइट. सो कल फंक्शनलाइजेशन ऑफ एल्किन्स, राइट. सो मिलते हैं कल सुबह ठीक 9:30 बजे विथ कैरोथर्स चैप्टर 5 problem solving with total detailed mechanism and also with explanation, right. So happy learning, take care.